All right, so who's ready to look at some code? Because that's what we're going to do today. First, me in 60 seconds or less. Thanks for that great introduction, maybe less. So I've worked at Vanguard for over 10 years. In that time, I've taken on a number of different roles, everywhere from UI developer to mobile developer, system tester, automation engineer. I've primarily focused on creating and maintaining our Selenium suite that we have. And for a brief time while I was on our mobile team, dipped into Appium as well. And I'm going to come here to share some of the fruits of that labor with you guys so that you guys can benefit from some of that experience. For those that are trying to take like lots of copious notes as I flash code on the screen over and over again, you're more than welcome to do so. But I actually blogged basically the gist of my talk out there on this OPC Soft blog that I'm a contributor for. You can also reach me at craig@ocpsoft.org. And I'll leave this slide up at the end if we have time for questions so that you can see that awesome URL again later. So first, I think it's probably a lot easier if we go through a very, very simplistic example so that we can all have kind of a shared understanding of how we would visualize this stuff. So that we can all kind of have the same pace to start from. So we're all going to put on our imagination hats. This is obviously a web page, not an Android application, but same kind of things apply, right? So we're gonna pretend that this is our Android application of our shopping homepage. It's pretty simplistic and basic. We can do things like type in here for what items I want to buy, and it's nice enough because our Android application has a list of all our items embedded within our application. So as we type things in, it nicely and filters to our list of things we want to buy, and we can select things from this nice pretty table and eventually hit the purchase button. Now, because we're mobile, not only do we have our Android application, but we have our iPhone application too. And the iPhone business, in their infinite wisdom, said, hey, that nice spiffy filter thing that you did for Android, that's really cool, but it's not showing the prices to our users, and we want to show the prices to the users before they get to the buy page on iPhone. So for iPhone, we actually have to type in some kind of search and then actually hit this search button, which is going to execute some kind of web backend thing to get the prices. And then we could list the same thing with the prices for our iPhone stuff. Now, again, because we're mobile, we have to take and pay attention. So this locator here for the table on iPhone is under the items list, whereas the same table for Android is under filter items, right? Because you got your Android team, you got your iPhone team, and the two of them don't talk to each other, and no one's ever going to come up with the same exact list of IDs for the two different platforms. So that's one thing that we have to consider, right? When we go from the web world to the mobile world, the first challenge is that locators are going to be different between the two, and we have to find some way of dealing with that. The second thing that we have to deal with is the fact that not only do the locators going to be different, but we have this potential of having different, small, minute differences in the implementation of the behavior between our applications, right? So here I just type in filter and it gives me a list, whereas on the iPhone page, the iPhone app, right, I had to actually click the search button, and there's no search button there on Android. But once we get through, right, we got our buy page to kind of let the user confirm that they want to purchase this thing, and you'll notice that these two things look very, very similar across our applications, as well do our confirmation pages, right? So we have our confirmation page for iPhone, we have our confirmation page for Android, and they look very, very similar. So we're going to focus on the shopping homepage as our example for where things can be different, both on the locator side and on the implementation side as well. Oops. So if we go back to our presentation, again, we have our two main challenges that we have to deal with for mobile, right? Locators are different, and implementation is different. There are some things, though, that we want to carry over from our Selenium web days, right? So page objects, and in particular, base page objects, and corporate base tests can give us a lot of functionality across our entire organization. And so we definitely want to keep those kind of concepts and kind of carry them forward into our mobile world. So now I'm going to kind of attempt the impossible. I gave a talk last year at SauceCon called Getting Rid of Flakiness, or Getting Rid of the F word, Flaky No More. And I'm going to attempt to summarize that 30-minute presentation in about 2 minutes so that we can move forward. So the gist of that talk was all around our base Selenium framework that we kind of have. And it all stems from this base Selenium page object, right? And we broke things out into so you have actions and finders and browser methods. So anything actions would be like actions.click, actions.isDisplayed, actions.is enabled. Any type of Selenium action that you could take, we kind of wrapped and put it in this actions object. Finder would be any of your driver.find elements and all of those things, finding sub-elements, et cetera, et cetera. Browser for browser.visit, so it would replace driver.get, or browser.minimize, browser.maximize, things of that nature. And a table helper to help you deal with things on a table. One of the big important things here is this abstract method for isLoaded. And this is something that everything that extends Selenium page object needs to implement. And that's how we tell whether the browser is actually on the page that we expect to be on. And if it's not, we're going to see in just a second, we're going to throw some kind of a custom exception that will pass back to the user with a lot more information. It takes a screenshot and says hey, when we instantiate this Selenium page object, if the browser isn't on there, then we're not ready to continue our test. Our test isn't where we thought we would be. So take a screenshot of what's actually loaded and display this nice pretty message to the developers and give them a lot more useful information. So how this works in implementation, we have our example of our shopping homepage web page object, right? So this is specific for web. And web is nice and clear, right? You have these private static constants for your buy locators up at the top, right? And they're not going to change they're not going to change in and of the website itself, right? The website is only doing one thing, as opposed to our Android and iPhone thing, where we're going to have to figure out how do we deal with the fact that Android does things one way and iPhone does things another. And the other thing that we have, right, is we have our action methods. In this case, we can buy an item on the shopping homepage, which we'll go through clicking and typing and all that kind of stuff. So that stuff is great, and it works for web. But how do we get back to our two mobile concerns, right? Locators might be different and behavior might be different. So we have two methods that I'm going to go through pretty quickly. The first method that I'm just going to kind of touch on is to essentially cheat. I'm going to call this cheating, and I'll explain why. If you feel like taking the cheating method, by all means, power to you. Just know what you're getting yourself into and the concerns that you might need to overcome. And if you say, look, the cheating method is so much simpler, and it is, that it's worth those risks, then by all means. And it's kind of become an industry standard for this cheating method. And I'll go over why I consider it cheating, and then what the kind of framework that we're going to start using at Vanguard, which is to really utilize polymorphism. And it's a little bit more complicated, but you get a lot of the benefits of pure computer science, design pattern orientation stuff. So if we go to our cheating method, which is essentially to use the page factory pattern, and if you utilize the page factory pattern, Appium provides these nice, lovely annotations for @findBy for Android versus iOS, right? So we could do things like @findBy if the thing is constant between Android and iOS, right? So our search input field just happens by magic to have the same ID across both platforms. But you could see our filtered item list and our buy button. Those things are different between Android and iOS. So if we specify a different @Android findBy or @iOS findBy, we can solve our first problem that we had, right? Our locators might be different. The second thing that we could do to solve our second problem of different behavior is we could simply just use an if check, right? To say hey, if the device type is Android, do this one thing. Else, if the device type is iOS, we could do this other thing. And we're simple, we're done. And we end up with this one nice, tiny, concise-ish page object that pretty much mirrors our web page object. And so it's nice and simple. And we managed to solve both our problems, right? So what's the big deal, right? Why not just do this and talk over? We could give you guys a couple more minutes and go to lunch early, right? So I'm going to call myself out. I gave the talk that I gave last year at a couple of conferences, and every time I gave the talk, I would hit a slide like this, and I would stand up on stage to people much like you, and I'd say, page objects should do 2 things and 2 things only, and test classes should do 2 things and 2 things only. And these are what page objects should do, and this is what tests should do. Do we have any developers in the audience? Like, who has a problem with what I just said? Yeah, classes should do one thing, right? We have this rule in computer science. There's actually a set of principles called solid, and I'm going to go over the 2 of them because they're the 2 that we violate the most grossly in our cheating example. The first is the single responsibility pattern, which states that classes and also methods should do one thing and one thing only and do that thing well. If we go back to our web example, I could kind of make the argument that our shopping homepage, like this kind of only does one thing, because like realistically, the second thing that this thing is doing is like, all right, so it has information about the locators up there, but realistically, like it's just assigning constants. Like assigning constants isn't like really doing another thing, right? So that was like my main justification in case anyone ever called me out on this. But if we go back to our page factory pattern, right, like this is not defining constants. This is like doing very complicated logic and just hiding it like underneath the covers under like Appium's find by page factory methods. And not only that, but we're actually violating the single responsibility pattern again by having this one lovely method clearly doing 2 things, right? We have like one thing that it's doing in the Android case and one thing that it's doing in the iPhone case, and like very clear violation of the single responsibility pattern. Not only that, but it also violates the open-close principle. So open-close principle says that code should be open to extension but closed to modification. And the big thing here is right now we only have two things that we're worried about, right? We have our Android phone and our iPhone. What happens if we wanted to add like an iPad case, right? In order to add an iPad case in something like this, like not only do we have to add all the like the iPad annotations up here, but we also need to go through like all of our page objects across all of our projects and say like where do we do this funky like if device type check stuff? And wherever we do that, we're going to need to like go into the code and say like, oh, like we can't just do else here. Like now we need to add like else if for like device type equals iPhone, and then we also need to add another case for if the device type equals iPad. And you got to like do that searching all over the place. What open-close principle is all about is saying, hey, if I wanted to add a device type for iPad, I should just be able to create whatever classes I need for iPad and not touch anything that's related to Android and not touch anything that's related to iPhone. So those are the kinds of issues that you may run into by going into this cheating method. So like violation of the single responsibility pattern, one thing that you may get into there is like you never want to do too much in one space, because what will end up happening is someone will be running this test and they'll say, oh man, like my iPhone thing needs to like click some magic button that we just added to the iPhone, right? So they'll come in here and they'll say like, oh well, it's part of the search for item like flow. So I'm going to go in here and I'm going to say like actions dot click for whatever of like magic button, and I'm not spelling and blah blah whatever, right? So you add that in there, and now all of a sudden like you've actually ruined the Android case, right? Because like that's going to run on the Android case too. But this is a relatively simple example, and like maybe that's super clear. But when you start getting into production, you get methods that are dozens of lines long or hundreds of lines long, because we all live in magic land of production where code is often crap. This kind of stuff gets harder and harder and harder to see, and violations of the single responsibility pattern become more and more apparent. And whenever you have like an A broke B type of error or defect in production, that it's typically due to some form of violation of the single responsibility pattern, because someone changed some line of code over here and it ended up breaking this thing over here, and they didn't realize that there was that kind of connection. So okay, how do we get through and follow the solid principles, and not only that, but also say goodbye to any no such element exceptions and stale element reference exceptions. So anyone that's in here that is using the page factory pattern, I'm sure you guys have run into this kind of stuff. And with our framework that I'm about to go over, we kind of avoid all those kinds of exceptions because we look up the elements exactly when we're planning to use them. All right, so how does our framework work? This stuff is a little bit complicated, but I promise it's a lot easier than it looks. It just looks a little bit more complicated than it really is. We separate out our page objects into a number of different classes. The first thing that we want to separate them into is actually an interface class. So every page object that you create an interface for it first. The interface is to basically say, what is the user behavior that the user can take on this particular page? Right, so for our shopping homepage, they could do two things. They can search for an item, and then they can actually continue to buy the item to get to the buy item interface page. So we have our abstract class, which means partial class. All these examples are in Java, but the concepts basically apply across the board. I'm sure there are ways of basically doing these types of things in just about any programming language. So if you're not a Java fan, just kind of bear with us. So the first thing we do is we have this abstract class that implements this interface, which means that any full class that extends the shopping homepage impl is going to need to implement both of those methods that are in that interface. And this particular common implementation is kind enough to implement one of them for our full classes. Right? So buy an item is actually common between iPhone and Android. Right? They're just like clicking the thing in the list once the list is there, and then clicking the buy button. So because that's common in both places, we can implement that in this common implementation abstract class. So that's the interface piece. We also have a Selenium mobile base page. Whoops. So this is part of our framework code here. And this does get pretty complicated, but it's framework. So I'm going to very briefly go over it so you can kind of like see what it's doing a little bit. But you guys don't ever have to deal with it because it's like part of the framework. The framework does all that stuff for you. So what we're basically doing here is we're saying we're going to tie some locator to this page. We're going to have an instance of that locator, and we're using Java generics here. And this whole bit of complicated mess is basically saying, like, get an instance of the locator, of the full locator class that's OS specific that we've tied to this page object, and assign all the values for it. And then again, just like before, check to see if it's loaded, and if it's not loaded, like throw an error and stuff like that. And one of the great things that this framework kind of gives us is this method right here for get page from interface. And this allows us, and I'm not going to go into how this works, but basically it allows us to pass an interface class and return back either the Android implementation or the iPhone implementation of that class based on how the framework works and stuff like that. So we'll see an example of this use as I go back in just a sec. So when I go back here, right, I can say that this buy item method is going to return some buy item page interface. And I can do that just by saying get page from interface of the buy item page interface, and that'll return in real, like at runtime, whether it's an Android or an iPhone class, based on whether the full class, which I'm going to go into in a sec, is either implementing Android or iPhone. So I mentioned we need to tie a locator to the page object. That's one of the things that we need to do. So we break up our page objects into a few different classes, right? There's this common implementation, there's the interface, and then for our locators, there's a common locators implementation, and then OS-specific implementations of the locators, and an OS-specific implementation of the page objects. So if I go into this common implementation of the locators, right? So this here has a list of all the buy locators that are common to both Android and iPhone. And you'll notice here it's got the search input field, the filter items table, and the buy button, which is common, but it does not have the search button, which is only specific to iOS, because that's going to be in our iOS implementation of the locators. So you'll also notice that this is an abstract class, meaning that we need OS-specific versions of the full class to actually implement everything. And just like before, so our search input field happens to be common between Android and iPhone, so we can set that here, so we don't have to set it at both implementations individually. And then we have abstract methods for setting the filter items and the buy button. So that's how we tie a locator class to a page object. And what that enables us to do is within this page object now, we can use those locators that we're specifying in the thing that we're tying it to. Right? So in our isLoaded method, we could say we know that we're on the shopping homepage if the locators.getSearch input field is displayed within 5 seconds. And if we wait 5 seconds and that particular element isn't found, then we know that we're not on the right page. We throw a screenshot and we send an error message to the users. Yes, real fast.
Line 19 is loaded method, right? The base
Mm-hmm.
is displayed method, which is kind of native method. So the thing is displayed in normal world will throw exception, not with false, if the object is not there.
Yeah, so we actually wrap all the Selenium commands in our actions method. So when you see like actions.isDisplayed, actions.click, all that stuff, we've taken care of all of like the exception handling and whether it should return true or false or return null or return exceptions. Like all of that stuff is wrapped up in our framework code.
Okay, because I saw the line. It says
Yeah.
throw another exception, which is valid, but it doesn't return true.
Yeah, so our actions.isDisplayed method will actually return you true or false rather than that exception. Yeah, it's all part of the framework. Good question. So this is how we have our common implementation of our page objects. From there, we actually have our OS-specific implementations of the page objects as well. So here we have our Android implementation that you could see extends the page that I just showed before. And now, not only are we saying that we're tying the common implementation of the Android locators to the page object, we're actually saying, no, tie like the Android-specific version of the locators to the page object. And you can see from there, this just extends the common locators from shopping home, right? And there were those two methods that we left out that were abstract for like, hey, how do you set the filter item list and how do you set the buy button? Well, on the Android version of the locators, we know exactly how to set those things because we set them to the Android-specific versions. So once we've defined that we're tying the Android version of the locators to our Android version of the class, one of the last things we need to do is tell the framework, hey, this is an Android mobile page object. And the way we do that is just by implementing this blank interface that basically just tells the framework, hey, this is an Android mobile page, not an iOS mobile page or something else. And the last thing we need to do, because we're extending our shopping homepage impl, which if you remember, implemented our shopping homepage interface, which had two methods, one for search for an item and one for buy an item. The shopping homepage impl implemented the buy for an item, but it did not implement the search for an item. So we need to implement the search for an item method in our own Android class here. I've implemented it in kind of a little bit of a crazy way of typing in one character at a time. It's mostly for demo purposes, so it'll look nice if I'm brave enough to actually run the two test cases that I have at the end of this talk. Kind of last but not least on our page objects, we have our iOS search page, right? So just like our Android page implemented the Android mobile interface, excuse me, the iPhone page implements the iPhone page interface, and just like the Android one did the shopping home pages for Android locators, the iOS one does the shopping home locators for iOS. And if we go in here, we could see that not only do we implement the remaining two methods that we needed to from the shopping home locators impl, but we're also adding something for the search button, right? Because the iPhone has the search button that the Android phone doesn't have, so we need to be able to set that too. And then once we set that in the tie to our iPhone case, we can see that we can do things like click the locators.getTheSearchItem button. So this is perfectly valid in this class. And if you notice, like if I go into our other class here for Android, right, and like type the same thing, and it's going to be like, yo, I don't know what the search button is. because I'm tied to Android, not to iOS. So this is the basis of our framework, right? So we have our implementation, our interface class that says the user behavior. We have our implementation classes that are common to where you can implement the common code and you tie the common locators to. Then you have the OS-specific locators that tell you how to find the OS-specific things. And then our OS-specific page objects, which give you the OS-specific behavior. So that's how we solve our two problems in more of a solid way, right? Is we're still able to tie locators to page objects through the class declaration right there. And we can specify differences in behavior because we're using polymorphism. When we go back to our test case, which looks even more simple, right? We utilize all the interfaces when we're creating our objects in our tests. And the test case itself is super simplistic, right? So you have, you set up your string for your item name and your string for your amount. And you say, hey, I want to search for an item on the shopping homepage. And then I want to get to the buy page by buying an item. And then I want to do some validation on the buy item page where I can validate that the item and the amount are correct. I can get to the confirmation page by going to buy page.submit order. I can validate that the stuff is correct on the confirmation page. And then lastly, verify that there is a confirmation number present. And finally, like log it out to the console or database or wherever you want to log your confirmation number out to. So I also made mention to corporate base page or corporate test, which can also yield a lot of benefits. So you can see here, like our shopping test is extending corporate mobile base test. And I'm not going to go into the details of the implementation of this because the details are obviously going to be corporation specific, right? Each of your own companies are going to implement this in your own way. But the gist of it is before any test runs on any Appium thing that you want to run on, basically you want to go through this. You want to say, hey, is the test running on Android or is the test running on iPhone? If it is, like set up the Android Appium driver or set up the iPhone Appium driver. And then lastly, give us access to our landing page that we're trying to get to so that we can utilize it within our actual test. Right? So if we're running on Android, then we set up the Android Appium driver and we say, okay, our landing page is the shopping homepage Android, and vice versa if we're running on iOS. And so that's how we can end up utilizing this landing page that we're getting in our test case. So now at the beginning of every single test, we know that like our emulator, our simulator, or our real device is already launched. Our application is already launched on there. Like our test case is just, what do I need to do on my application to test my application? And then I'm done. And then also in the corporate-based test, you would handle like closing down the emulator, simulator, or real device, releasing it, whatever you need to. So I'm going to wrap this up. This particular test case is basically the same exact test case as the one you just saw. The only main difference is that I'm extending our Selenium-based test rather than our corporate mobile test, because if you noticed, I didn't have Android emulators and simulators or iPhone emulators and simulators. This is a Chromebook. I don't own anything Apple, so connecting to anything iPhone simulator would be next to impossible. But we're gonna be brave. We're gonna demo this thing right now live. So what this test is gonna do is it's gonna go through our process. Looks like I have some saved things. Hopefully, it's gonna go through our by process. Right, we're gonna start our Android test here because that's the device type that's uncommented. We're gonna launch our Android application and go through our test. So we're going to type one letter at a time. We could see what it's clicking on because I kind of overrode what our framework is doing to give you a nice little highlight. And you can see that it's able to purchase an item, get to our buy item page, it's validating everything that's on the buy item page, purchasing an item, going to the confirmation page. And we can see here in our console, we have a green bar, and we have our shopping Android test that was able to simulate starting the Android emulator and go from there. And if I comment out this line and uncomment out this line and change absolutely nothing about the test case itself. So again, I'm basically just setting like normally the device type would be controlled through like a CI parameter or something like that, right? You can decide within your company how you're going to determine whether you're going to run iPhone or Android. But for demo purposes, I just used a quick little enum there. And you can see here, we're going to run through the same exact test with its slightly different flow without changing any of the test case code itself, that it can go through the iPhone page as well. So we go through our search page, we go through our buy page, we go through our confirmation page. And we get super nice, clean, succinct, like super easily readable test cases where like just about anyone can like read this test case and tell me like exactly what it's doing. It's all super clear. Notice like there's no Selenium commands itself in the test case. All the Selenium commands are technically actually embedded within our framework code itself, not even in the page objects. So the test cases basically just have like calls to page objects or assertions. And then in the page objects code, you're making calls to our framework, which are then making the calls to the Selenium commands to get you there. So with that, I will throw up our summary slide. Right, so two factors to deal with for mobile, right? Differing locators, differing OS behavior. Two things that we want to copy over from our Selenium web days of page objects and base tests. There's basically two ways that you can compensate for those mobile problems. We can cheat, kind of like what we saw with the Appium Page Factory, the OS at find bys, and putting in that logic in the for if Android do this, if iPhone do that. No complaints from me. If that's what you guys want to do at your company, feel free. It certainly works. Just know that you're violating some of the core computer science principles. But as long as you're okay with those risks, you can see it's certainly much faster and succinct. But if you want to do a more solid approach, you can implement something like this framework that we have here, utilizing actual polymorphism, where we basically tie the locators back to the page declaration. And we're able to locate which version of the page object that you want to instantiate, be it either Android or iPhone through the framework itself, through the use of the interfaces of either the Android implementation interface or the iPhone interface. So with that, I'll leave you with the last slide. You can feel free to reach out to me at craig@ocpsoft.org. You can feel free to view my blog, which basically summarizes this 30-minute presentation in about 20 or 25 long pages with lots of code and stuff like that on the site. And it looks like we have like 1 minute or so for questions. Yes.
Hey, I am Shyam. So, so we also face the same situation in my company. So it's like there was a lot of if-else-if conditions, like if driver instance of Android driver do this.
Yep.
So we decided to overcome this one, and we found out quite different way. So rather than using interfaces, we went with the custom annotation. Like if it is an Android class, just specify it's an Android. Then when you start the test, you just create an hash map and just fill in all the corresponding Android and iOS classes, and just use the reflection to find out which class need to be invoked.
Yeah, that's basically the same thing that I did. So your method was basically just to use an annotation at the top of the class rather than an interface, and you still used reflection to go through and find out which one was which. So I would argue that's basically the same pattern.
Yeah, why we went for that? Because we had a lot of these so-called cheat codes. So we want to adopt that one along with the polymorphism. So all the new test cases, we following the polymorphism subclass for Android and iOS. But we needed to support the existing one also, which has the if-else-if conditions. So with the annotation, it was easy to adopt it.
Okay. Yeah, that would work. Another really quick approach would actually be to create a factory where you could say, okay, I want a class of like the by page interface, and if you created a factory and said, okay, the Android implementation of that is this class, the iPhone implementation of that is this class, and then you could say page factory.getMe instance of the by page or whatever.
Yeah, we did that actually.
The problem with that, and why I decided to go with this, and probably why you guys decided to go with the annotation, is you then need to create a factory for every single page object. And I felt like using reflection and doing things this way, same as you, was a little bit nicer of a solution.
Thank you.
Yeah. Looks like we're out of time, and I don't want to hold people up for lunch. If anyone has any questions, please feel free to come see me. I'll be around for the rest of the conference, and I love talking about all this stuff. I'd be more than happy to give you guys like a more in-depth demo. I kind of had to go through an entire framework in 15 minutes. So if you guys want to see more stuff, I have some example projects and the framework itself that I could show you on my laptop. Thanks.